Hello guys, my name is Ashish Yadav, and today I will be teaching you a very important concept of probability of class 12th, that is Bayes theorem. But before moving to Bayes theorem, we must be knowing what a total probability theorem is, because Bayes theorem is just a step ahead of total probability theorem. Let's recall it guys. What's a total probability theorem is? Total probability theorem or TPT. Let's analyze what the statement says of total probability theorem. Let E1, E2 up to En are mutually exclusive and exhaustive events. What are mutually exclusive events, guys? You must be knowing that mutually exclusive events are those which do not have any common intersection in them. Okay, and exhaustive means they cover up the entire sample space, or you can say the entire domain. Let an event E is defined in the same sample space. Okay, let an event E is defined in the same sample space. Let's picturize it guys, because picturizing makes things easier. Suppose these are events. This event is E1, this is E2 up to these are En. As you can see that in this particular figure, neither of any of E1, E2 or En up to En, they do not have any common part. That's why they are known as mutually exclusive events. And since they have covered the entire sample space, so they are known as the exhaustive events. Let's say an event E. This event is E. This particular event E is defined in the same sample space. Now if I ask you what is the probability of occurrence of this particular event E, then this theorem gives the particular answer. What that is? Probability of occurrence of E. Just imagine guys, just apply the logic that particular event E is being occurred because of E1, because of E2 and up to so on En. So we can say that what would be the probability of occurring of E? Probability of occurring of E would be equals to probability of E1 intersection E. Means E1 and E both occurred at the same time, this region, plus probability of E2 intersection E, that is this region, up to so on probability of En intersection E. Or you can say that probability of occurrence of event E would be equals to sigma probability of E intersection E I from I1 to N. You must be knowing the condition of conditional probability, that probability of occurrence of event E when ER has already happened. Probability of occurrence of event E when ER event has already occurred. It was probability of E intersection ER upon probability of ER. So here we can write that probability of E intersection ER would be equals to probability of ER into probability of occurrence of E since ER has already happened. So now we can state that probability of occurrence of E would be equals to sigma I raised to 1 to N probability of EI into probability of occurrence of E since EI has already occurred. This was the total probability theorem. Now what a Bayes theorem is? Since you know that particular event E is being occurred by means of E1, E2, E3 up to so on up to En. So if I ask you a question that say event E has occurred, okay, now the event E has occurred, and I ask you what is the probability that event E has been occurred because of say E2, or event E has occurred of because of EK. So Bayes theorem says that since event E has already occurred, what is the probability? What is the probability that E has been occurred because of EK? EK may be any event. So what we have given? We have been given that event E has already been occurred, guys. This particular event E has already been occurred. Now what is the probability that EK must have been occurred due to which event E has occurred? So you might be knowing that it would be equals to probability of EK intersection E upon probability of E. Guys, this probability of E is the total probability of E that has been taken from the total probability theorem. We can write it as one more step, that it would be equals to probability of EK into probability of E since EK had occurred upon probability of E, which is the total probability of occurrence of event E. Let's take an example, guys. What I am trying to say, let's understand this by means of an example. Okay, I'm not gonna write the total question language. I just give you the hint. Okay, guys. Let's say there are three boxes. This box is box A, this box is B, and this box is C. Okay. These three boxes have probability of being chosen differently. Say probability of A got chosen is 1 by 5. Probability of box B would have been chosen is 2 by 5. And probability of box C should have been chosen is say 2 by 5. Okay. Now this particular box A contains 1 red and 4 black balls. This bag B contains say 2 red and 3 black balls, and this bag C contains 3 red and 2 black balls. Okay. Now I say that an event E saying red ball is chosen. Red ball is chosen has been occurred. So I ask you, what is the probability that event E should have happened? Means you have been given three boxes. Each boxes contain different number of red and black balls, which I have already been mentioned. Now you pick one ball and you found it to red. What is the probability that this particular ball would be a red ball? So you can say that you might have chosen first bag, and probability of getting a red ball from first bag is 1 by 5. From second bag is 2 by 5, and from third bag is 3 by 5. So I say probability of getting a red ball. What would be that probability? That you have chosen bag A, and with that bag A, a red ball has been taken out. Or from bag B, a red ball has been taken out. Or from bag C, a red ball has been taken out. So you can write it as probability of A, that is you have chosen the red ball. And since this red ball has been, this bag A has been chosen, a red ball has been lifted. Or probability of B into probability of E intersection E by B, or probability of C intersection probability of E C. This is quite simple, guys. This is known as total probability theorem. Okay, this is the total probability theorem. So let's see what this goes. 1 by 5, 1 by 5. Okay, 1 by 5 is probability of selecting red ball bag A, and 1 by 5 is from bag A red ball occurs. 2 by 5 is the probability of selecting bag B, and what's the probability? It's 2 by 5. Yeah, 2 by 5 is getting a red ball out of bag B, plus 2 by 5 selecting a C bag, and 3 by 5 selecting a red ball from bag C. So if we calculate it, we will get 25 at the denominator, 4, 6 and 11 is to 25. Now guys, I have mentioned about the Bayes theorem. This particular event E, what? Selecting a red ball has been already occurred, means you found out that the ball which you are having in your hand is a red ball. Now I ask you that what is the probability that this particular red ball which you are holding in your hand right now has been come from bag B, or we can say that event E has already been occurred. What is the probability that it has been occurred due to event B? So this is known as Bayes theorem. Once you know that a particular event E has been occurred, then Bayes theorem states that since event E has already been occurred, you tell me the probability that it has been occurred due to a particular event, say EK, E1, E2, it can be anything. So guys, what would be it? You can apply the conditional probability formula, probability of B intersection E over probability of E, and here you can apply probability of B into probability of E by B over probability of E. Guys, you know, you have just calculated that probability of E is 11 is to 25. Probability of selecting a ball B, 2 by 5, and ball B from bag B, a red ball. Yes, a red ball has been taken out. The probability is 2 by 5. Okay guys, it's 2 by 5. So if you calculate it, you will find it to be 4 is to 11. Guys, this is known as Bayes theorem. What we have done in the Bayes theorem is, first of all, we need to understand what a total probability theorem. I'm surely confident that now you must be knowing what a total probability theorem is. Once you know that a particular event E has been occurred due to so many smaller events which are mutually exclusive and exhaustive, and I ask you a question that since event E has occurred, tell me the probability that it has been occurred due to an event, say EK, then Bayes theorem gives the answer for this. So guys, this particular session is all about Bayes theorem. I hope you understood the concept very well, and just let me know whether you understood it or not. Thank you guys.